Hi, in this lecture, I'm going to introduce the techniques being used to solve the linear equations for the linear circuit problems. And there are mainly two techniques you can use. One is just after you list all the linear equations, just directly solve them using substitution. And the other one is to use linear algebra equations to inverse that coefficient matrix and do the calculation. But we're not going to calculate the inverse matrix by ourselves. We can use MATLAB to do this for us. So let's look at that example first. This is our circuit analysis lecture part 2. Here's an example. Here's a voltage source, and one little resistor, and one more, and one here, and one more voltage source. And this is 40 ohms, this is 20 ohms, this is 2 ohm, this is 8 ohm, 6 ohms, 6, 4, 20. So first, based on what we learned in the past, and we know KVL, we know the match current method. So let's just draw all the match currents first. So let's assume this is I1, this is I2, this is I3. Keep in mind, match currents are not necessary to be the physical current, the really current flowing through all the resistors. It can be for this guy, it is for this guy, I2 is the current flow through this guy, definitely, no problem. But for the resistors being shared between the two meshes, the current is not I1 or I2. It's going to, so the effective current flows through this resistor will be I1. If you're looking from top to bottom, it's going to be I1 minus I2, like this. Okay, keep in mind. So the match current method is just so convenient. They are not really physical currents flow through every single component. So let's list the equation first. Let's use KVL. And if we start traveling from here, if we have a little person here, we're going to walk through the mesh. And so the first one, the first sign this person is going to see will be the minus sign. So we need a minus 40 volts. Plus, because this is plus to minus, since I1 is flowing in that direction, so it's causing a voltage drop across this resistor from left to right. That's why it's going to be 2 times I1. Then this one, it's A times I1 minus I2 equals to 0 according to KVL. Keep in mind. And now the second match. If we start from here, then that's A times I2 minus I1, then 6 ohms, which is 6 I2, then 6 ohms again, which is 6 ohms times I2 minus I3 equals to 0 according to KVL. Now the third match, still starting from here, then we are first seeing a plus sign for the 6 ohms. So it's plus I3 minus I2, and then 4 ohms, which is I3 directly, then 20 volts. So it's plus minus equals to 0. Okay, now let's take a look at the two methods to solve this equation. Because you can see that you have how many variables? 3 variables, right? From I1, I2, I3, and 3 equations. So theoretically, you should be able to solve it easily. And so first, let's simplify it. We're going to use a method 1. To simplify, we're going to move all the coefficient of I1 to here, to the first column, and then I2, I3, then constant, then the other side of the equation. So let's look at the coefficient for I1 first. And we are getting 10 I1s and AI2 and no I3, right? So no I3, but there is a 40 on the right side of the equation. The second one, how many I1? It's just minus AI1. And then I2, it's 20 I2, I3 minus 6 I3 equals to 0. The third one, no I1, and then minus 6 I2, 10 I3, and equals to minus 20. So these are the three equations. If we just do a substitution, I'm pretty sure you can solve it. So what I'm going to do is I will directly label these equations like equation 1, equation 2, equation 3. And from 1, I can get I1 equals to something, right? If I divide, for example, 2 on both sides of the equation, like from equation 1, I'm getting 5I1 minus 4I2 equals to 20. So I1 equals to 20 plus 4I2 over 5. Okay, that's how you get I1. And now I can combine 4 and 2 to cancel I1 in 2. But you can see that actually you can simplify the second equation really quickly. I mean, to reduce the calculation load, right? So just divide by 2 on both sides of the equation. So you're getting minus 4 I1 plus 10 I2 minus 3 I3 equals to 0. Let's label this as 5. And now let's combine 4 and 5. So we can cancel I1. So substitute I1 in 5. Use the fourth equation over here. So you are getting minus 4 times the entire thing here, 20 plus 4I2 divided by 5 plus 10I2 minus 3I3 equals to 0. So let's simplify this one. So we only have I2 and I3. So we can combine with the equation 3 and to solve for I2 and I3. So this one is giving you, it's a lot of numbers over here, but let's try to get it here. So if we times 5 on both sides, we're getting minus 80 minus 16I2 plus 50I2 minus 15I3 equals to 0. And then 80 is minus 80 plus 34I2 minus 15I3 equals to 0. Okay, so let's label this as number 6. And by looking at number 3, we can definitely, calculate I2 and I3 over here. So combine 3 and 6. So which one should we cancel? If you look at here, it's I2 and I3. So seems like if you turn I3, the coefficient for I3 to 30, so you are able to cancel I3 over here, hopefully. So let's do that. From 3, we're getting, so times 3 on both sides is minus, this is from number 3, so we're getting minus 18I2 plus 30I3 equals to minus 60. And from 6, we are getting, let's move this guy to here, move 80 to the right. So 80 is 102I2 minus 30, no, times 2 here, sorry. So it's going to be 68I2 minus 30I3 equals to times 2, right? So it's going to be 160. And then number 7, number 8. Let's come plus 7 and 8 on both sides of the equation, so you can cancel I3. So you're getting combined 7 and 8, and you are getting 50 I2 equals to 100. So I2 equals to 2 amps. Okay, that's I2. Then you can put it back here to calculate I3. Okay. So substitute I2 over here, and let's calculate I3. So I3 equals to, if you put it here, then you are getting, yeah, let's pick up the easier one. Let's put it here. So this is minus 36, and move it to the right. So you're getting 36 minus 60 over 30. So this is minus 24 over 30. And this is, this is minus 0.8. Pretty accurate. So now you have I3 and I2. Let's find the equation to get I1. So you have I2 already, so let's put it here. So I1 equals to 20 plus 4 times I2, which is 2, over 5, which is 28 over 5, which is 5.6 amps. So now you have all the currents being solved already, and the next step is to calculate the voltages at every node. So let's name the node as, for example, V1, V2, V3 is pretty simple, and let's call this V0. And this is ground, so this is 0 volts all the time, no problem. So you only have 1, 2, 3, 4, 4 different voltage nodes, and several currents as well. But keep in mind, the match currents are not the currents flow through every resistor. So we have to find out, since I already defined I1, I2, I3, so I have to, if I am asking you to solve the circuit, you need to know that you are not done yet, right? Since you just know the match current, but they are not the current, physical current flows through this resistor, and just these 2 resistors. But this is I1, no problem. This is I2, no problem. This is I3, no problem, because these guys are not sharing the current with other resistors or other matches. Only these ones has problems. So let's name it as I4, this is I5. So we have these unknown variables to solve. V1, V2, V3, actually V3 is given, and I4, I5. After that, after we get these ones solved, the circuit is solved. So which means there are no unknown parameters anywhere. So all the voltages and all the currents are known after you solve it. So let's take a look. Now, after you solved all the match currents, everything becomes easier. Okay, you just need to use Ohm's law to calculate all the voltages and currents. So I'm going to give you some examples, and I'll let you look at the ways to get everything solved. So now we know I1, I2, I3 already. They are solved. And so I4 equals to what? I4 is the effective current flows through this resistor. So it is actually I1 minus I2, because I1 is going down. It's the same direction as I4. But I2 is trying to cancel part of the I1. Finally, give you this effective I4 flows through this resistor effectively. And I5 is I2 minus I3. Okay? And this is I1, this is I2, this is I3, no problem. And what about So VO is definitely 40 volts. V1 is, what is V1? I have to use 40 volts minus 2 ohms times I1, whatever I1 is, right? So I1 is 2 amps, like as we calculated. So V1 will be 36 volts. And what about V2? V2 is V1 minus the voltage drop over here. So it's going to be V1 minus 6 times I2, which is, what is I2? 0. I2 is, no, I2 is 2 amps, sorry. So I1 is actually 5.6 amps. This is not right. 5.6, so it's 40 minus 5.6, so 11.2, right? So it is 28.8 volts. And V2 is V1 minus I2. I2 is 2 amps. So it's 28.8 volts minus 6.2 amps, which is 12, right? So this will be 16.8 volts. And V3 is definitely 20 volts. That's a voltage source on the right side. So after that, all the currents are solved, and the circuit is being solved as well. So that's how you solve a linear circuit. So this is the way you can do, it's pretty slow because it's a substitution and it will take a lot of time. We are not going to require you to do this all the time, but I think I should introduce a better way first, which is using MATLAB to solve a linear equation. And you still need to do the same thing here. And after that, that's method 2. After that, you just list the coefficient matrix out of this equation set. So let's call it matrix A. So matrix A has the first column has all the coefficient for I1. So this is 10 minus A minus 6. And the second column will be the coefficient for I2. If there's no I2, like this one, then just list I2's coefficient to be 0. We are getting minus A, 20, and 0. Actually, there's no I1. Sorry, this is I2. So you should align it. I didn't align it. I'm sorry for that. So coefficient for I1 in the third equation is actually 0. And the coefficient for I2 is minus 6. Okay, now it's right. So coefficient for I3 is 0 here. This is minus 6. This is 10. So that's your coefficient matrix. And also you need a matrix B, which is a constant matrix on the right-hand side, which is 40, 0, and minus 20. And now what we need to do, because the left side of the equation can be represented by A times X. X is a current matrix, the column matrix, equals to B. So it is actually something. So A is a square matrix, and X is a column matrix and equals to a square matrix. And what you can do is you times the inverse matrix of A on both sides of the equation. So you are getting A inverse times A times X equals to A inverse times B. And this can be canceled. This is going to be matrix 1, and times X is still X. So now you get X equals this. So eventually it's going to be a current matrix on the left side equals to something. So what you need to do is just in MATLAB get the inverse matrix of A and do a matrix multiplication with the constant matrix, so you can get all the currents in the column matrix. So let's try it. I'm going to show you how to do that in MATLAB really quick. So first, you need to type the constant matrix into MATLAB. And this is not going to be taught over here. If Engineering 104 will be the required class before you get into here. So you are supposed to know that. It is 10 minus A, minus A, that's the first row, and 0, and minus 8, 20, minus 6, That's the second row, 0 minus 6, and that's a third row. Okay, so that's matrix A, which is a constant matrix. And now matrix B, the coefficient matrix, and then the matrix B is a constant matrix, which is 40, 0, 20. Okay, and then you just need to get the current matrix equals to inverse, that's the inverse function, inverse of A times B. Okay, something's wrong. I guess B is not. Did put B there? Overwrite B. And do this again, so now I get the right answer. All right. So these are the two main techniques you can use to solve a linear equation. And in your homework assignments, you are allowed to use MATLAB, and also in the exams, you are allowed to do MATLAB as well. Okay, if you have a calculator can solve linear equation like this, feel free to do it. Okay, I'm gonna see you in the next lecture.